And it seems like a long way away, but with senior mass,
What is it?
New girlfriend type of
I was
thing.
gonna say,
Yeah.
that's not what we're.
I was
Talking about that.
talking to your dad.
That's a weird name to have for.
Wait, why are you talking to your dad?
I was texting my dad about baseball.
Oh, that you
He's
were
laughing.
Hey, you're a student athlete, not an athlete student.
That stuff doesn't wait for
Bro, what?
baseball.
What'd you get on the
Charlie
quiz?
Finn is
What'd
absent.
you get on the quiz yesterday?
Yeah, that's a legit.
Actually,
Actually,
is
I knew Finn was gonna be absent.
what'd you get?
He sits by you.
This was making sense.
What'd you
Oh,
get?
yeah.
Yeah,
I knew she
20.
was gonna be absent.
Eli got a 24 year.
Not sure how it works.
Annalise is absent.
You would have
Miles
got
is
18 that year.
absent. Gosh, we have a lot of
A
absent.
lot of absent.
Yeah, see there it is.
Are people already leaving for Thanksgiving?
Oh, there's Miles.
Into the great wine.
You missed the other part of the conversation. All right. Today's lesson. Two things to learn today. One is how we put together and take apart logarithms. Oh, December 9th will be our test. So
That's
we gotta
math
get
league.
through a bunch of stuff.
It's a math league.
Boy, are you gonna have fun that day. Okay, so one of our jobs today is how to learn how to put together a big chart logarithm. You did this last year. Does anybody remember how to condense this into one logarithm? So instead of having a log minus a log, anybody remember?
Log, parentheses, x minus 1.
No, but you're close. It's going to be log parentheses x divided by y. Because in logarithm land, the difference of logarithms translates into the quotient. All right? So if you have a log minus a log, you're going to put them together, but when you put them together, it's as a division. Okay? This is not distributive. You don't factor out log. You're rewriting two logarithms as one. Okay. Now, if this one was a division, what do you think this one's going to be? Multiplication. But this one has an added complication. We're going to put it together into one logarithm. But we have to deal with the 2. Does anybody happen to remember what we do with that 2? What did you say? Erica, were you saying something?
2x times y?
No, but this does belong to the x. It's an exponent. So this is the log of x squared. Coefficients are exponents in logarithm land, okay? So that 2 becomes x squared. Now I have the log of x squared plus the log of y. So when I put them together, it's going to be the log of x squared times y. Okay, let's look at this one. Okay, think about PEMDAS. PEMDAS says do exponents first. So let's take care of this. This is going to become the log of z to the 1/3 plus the log of w to the 2/3. Would you agree with that? So when I put them together as one logarithm, and that's our objective, all of these problems are going to be the log of one thing. Putting them together. What is going to be inside the parentheses? That's a plus.
Z 1/3. And W's 2.
Yep, z to the 1/3, w to the 2/3. They get multiplied.
Could you put that as a cubic root?
You absolutely could. One cube root, these denominators match. So you could rewrite that as the cube root of zw squared. Absolutely you can. Would not be a requirement, but is actually fine. All right, here we go. What happens to the 1/2?
Goes over.
Becomes an exponent, right? And the 2/3 becomes an exponent. What's 16 to the 1/2? Uh-oh, review question. That's 4. Why is it 4?
Square root.
Because square root. So this is just a log of 4. What's this one? Also 4. Because what does this say? The cube root of 8 squared? Well, wait,
Where's the 2?
0.
that's just 0, right? That's just 0. Now notice, we talked about this the other day. If I made this a division, wouldn't it be the log of 4 over 4? Which is the log of 1. And remember, when we talked about that, what did that always equal? That had to equal 0. So the answer to the problem is 0. Obviously, if you subtract these, they're the same, you're gonna get 0. All right, see if you can do this one on your own. Can you do that one on your own? ln is a logarithm, so do not be confused by that. ln is a logarithm. The only difference is our answer is going to be ln instead of log. It's going to be ln. Something. Can you figure out the something? Eli, what'd you get?
62.
62?
Yeah, I think. Or is, would you do 2?
Is it ln 2 to the 3rd?
Well, I would you, for 2 to the 3rd, would you do 2 times 2 times 2, or would you just leave it like that?
Well, so this is ln 2 to the 3rd, right?
Yeah.
What's 2 to the 3rd?
8.
So we'll say ln 8.
Yeah.
That's ln 8. Plus, what's this?
8. Or 6.
6.
Oh, well, that's
48.
Isn't this ln 36 to the 1/2?
Yeah.
Which is ln 6, because 36 to the 1/2 is square root.
I put,
And then what am I gonna do with my 8 and my 6?
times.
What times them?
Yeah.
So that's gonna be ln 48. Your answer's ln 48. Did anybody get that? Somebody did? Good job. All right, here we go. Last one. Now, one more comment, just to make sure that we're not confused. If there had been, let's say, a base 5 on here, nothing would change, except your answer then would be log base 5. The base is irrelevant. It doesn't change any of the way we do things, okay? It's just along for the ride. So don't ever be confused if you have a different base in there. Now, when it could be hugely problematic is if that base is 5 and that base is 7. That is trouble, but I'm never gonna do that to you. The bases are always gonna be the same, so your properties work like they work. All right, so what are you gonna do first here?
What we're going to do next time?
So that's gonna come up here. So would you agree that's gonna be the log of x to the 4th, y to the 4th? They both get the 4. And this is gonna be minus the log of
X to the 3rd.
x to the 3rd. So it's gonna be a division, would you agree with me? x4, y4 over x3.
Dang. So I got.
Well, we gotta simplify if we can.
Oh.
Can we simplify?
Yeah, X. Just X.
X, y4.
Yeah.
So just like regular everything we do, if you can simplify it, simplify it. Cooper, where is your lanyard?
Oh, I put on my bag.
Cooper.
Braden's wearing someone else's.
Are you wearing someone
No, I'm
else's?
kidding. I'm
no,
kidding.
no, no, no.
Oh,
Because that's big trouble.
Wait, why does name get?
is that worse than having an action?
Why does name get written down?
Infraction.
And
All of them, they don't have their language on.
Braden's the later on.
You didn't have it on.
Oh, then you reminded someone else.
Yeah, so you came into the room without your lanyard on.
Wait, is having someone else's worse than having none?
Yes, that's a double infraction.
How do you catch that? Like, if you caught that, someone
I
walking?
have caught that, but I sure missed a million of them, but, yeah.
You should keep stats of how many people.
That's all over the school with short.
Next,
Who do you know?
I didn't even see it.
I remember before I knew, 2 years ago, 2 years ago, 2 years ago, I caught Gannon Knowles.
Oh, yeah.
I didn't know him at all, but he never, oh, I got one in my bag, So, he had like, I don't know, a bunch in his bag, but he put one on, and I looked at it, cause that was gonna be an infraction, I forget the name it had on it, but a kid walked by, this was out in the hall, a kid walked by and said, "Hi, Gannon." Gannon? So that's how I
So was that three infractions?
Did
he get 3 for that?
All right, now. And actually,
Oh, yeah.
people think I enjoy writing them. I don't, because it just takes time out of my day.
oh, you're just helping them.
Just hold them accountable.
Just
I
build
would so
integrity.
much rather we follow instructions.
You're just building them integrity, doing the right thing.
Great wide.
Okay.
I didn't even see him put it.
It's like the world's fastest 600.
All right, here we go.
You're like,
This is the opposite. Now we're going to take them apart. Do you see how these are being multiplied?
Log X plus.
So when I pull them apart, it's going to become an addition. They each get a logarithm. Oh, that shouldn't be log, that should be ln, sorry. That's
Oh, yeah,
ln.
you're right.
So ln x plus ln y. Each letter, when you pull them apart, each letter gets a logarithm, okay? So I have an ln x, I have an ln y, I'm gonna add them because that's a times, okay? Now, there's gonna be an ln x in this problem, and there's gonna be an ln y in this problem. Because those are the letters that I've got. What else am I gonna do?
Wait, is it?
This is log.
I thought it doesn't matter.
This one's log. All right? Doesn't matter what, Michael.
No, I didn't know if it mattered if it was L.
Yeah, no, it needs to match. Okay, so I'm
So we put 3 in front of
a
that,
3 in front of the x
minus 4
minus
in front of the log.
a 4 in front of the y. Does that make sense to
Yeah.
everybody? Those are your properties.
Wait, would log x to the third be right?
That would be like step 1. This is the final step.
You have to get to the first, like, yeah.
Okay, that could be a first step, yes. All right, how about this one? Again, I'm gonna get this right. We have a log x and a log y.
And then is it log X?
1/5?
Into the 1/5.
1/5
log X.
and 1/5, because they're both under there,
Yeah. Minus, yeah.
and a minus in between
Because
them.
the Y's on the bottom.
Yep. It's top minus bottom. Are you getting the hang of this?
Yes.
All right, so what's this one gonna be? Again, you're gonna have log x and log y,
You're gonna have 1/4 for X,
1/4 on the x.
but just nothing maybe for the.
And minus the y. So in this one, they were both under the radical, so they both got the 1/5?
Yeah.
In this one, only the x is under the radical, so only the x gets the 1/4. Number numbers are not treated any differently. This is gonna be the log of 100 plus the log of x squared. That will be my first step. So this, I know that's not a y, but you treat it like a y. It's a separate piece of the problem. So the log of 100 plus the log of x squared, and what could I do with that?
What?
2 log x.
2 log x. But this one's tricky. You gotta remember yesterday.
E, it's
Log of 100. What is the log of 100?
1.
2. Michaelotti, why is it 2?
Because, 10
10
squared.
squared.
Yes, Michael, there's always a 10 to the base.
The
That's what
log
I'm
of
talking about.
100
Good luck,
is the
Doc.
log base 10 of 10 squared.
It's
isn't
all
it?
right.
So you gotta pick up on that, kids. You know that an LOG means base 10s, and 100 is a power of 10. When this number is a power of your base, you can simplify. If this had been 90, I couldn't do it. I'd be done, log 90. But as it is, it's 2. This one's gonna be very similar, because this one starts out ln 30 plus ln e cubed. What's ln e cubed? We talked about it
Cancel out.
yesterday. Those are gone, so your answer is ln 30 plus 3. Okay? All right, let's get our calculators out. And the first thing I want everyone to do, all right, listen, first thing I want everybody to do, because this can be the case on all different shapes of calculators, all right? And mine is very old. Some of you have newer fat ones than I do, and some of you have the new skinny ones, okay? I need everybody to do this. I need you to press your math button, and then I need you to just arrow down. There's a whole bunch of things there. Arrow down, and see if you can find log base.
Base.
Okay? So that's where we're going. Now, I cannot find that because my calculator does not have that. Okay? And it's okay. We're gonna do both kinds. If your calculator has log base, when you press that button, it throws up a couple of boxes for you to fill in, doesn't it? And so when the directions say, find the log base 3 of 4, you just fill in the 3 and the 4, and it gives you the answer, which is 1.26.
2.6.
I need 3 or 4 decimal places. 10,000. So 1.2.
6.
9. Do we agree on that? 10,000, 4 decimal places. Okay? Now, I want everybody, even those of you that have that button, I want everybody to type in, there's the problem right there. I want everybody to type in log 4 divided by log 3. If your calculator doesn't close this parentheses, please close it. So log 4, close parentheses, divided by log 3, and what happens? The same answer. So all of us can do this problem on our calculator. Some of us will use that button, or all of us can do it this way. It doesn't matter. Okay? Got it? So notice this order is important. This number that's on the bottom, the base number, goes on the bottom. So log 4 divided by log 3. So I need everybody to do the rest of these problems. If it looks like a decimal point, it is a decimal point. make sure you are rounding to the nearest 10,000. So you need 4 decimal places.
Good job, Royce.
Thank you.
Should I give some more people some chances?
I don't know. Did you do it? Would you do it?
Yeah, but
Then you got it right.
I'm nervous.
What are we gonna do, laugh?
Probably.
Oh, you beat.
I got one.
If you typed in what I told you to type in, you will be right. If you round it.
I think my parents are going, but they can't meet them.
I think my mom got you on.
Practice 2 from last time.
I wonder if there's should be one.
And you
He was
do
like-
need, come on.
He randomly just
Oh.
got mad at me
Come
for
on,
anything I've
Trace,
ever done
somebody get
my
up here
entire
and do
life.
the D&D.
The Giants were here, talking about like the football thing we were at. He was like, oh, boy, I've never seen you as a
And then later that night he got mad at me for everything I've ever done wrong.
Yeah.
I thought he said it was.
When you press the log button on your calculator, the base is 10, right? When you press the LN button, the base is E. So if the base is any other number, then you have to do this, right? You can press log if it's a base 10, LN if it's a base E. You have to do this if it's any other button. Now, just for kicks, I'm gonna check these in a second. Type this in again, but instead of log, type LN. LN is divided by LN.
So you want to go around and just say this
You type this in, Eli?
Sorry.
It's the same thing. So the moral of the story is kind of what I was saying before. The base doesn't matter, right? The answer is going to be the answer. You could do base 7, you could do base 52, you could do any base. Okay?
What's the point of log and L for both?
Oh, you are going to find out.
Whoa.
Let's go. We're gonna find
Okay.
out.
All right, let me check them. For B, I got 0.3. That is not what I got for B. I could have typed it in. Double check. That's what you got.
I got that. I got that.
Try.
And so did I, after I typed it in correctly. That is exactly right. All right, for C, yep. D,
Wait, is it 20?
yep. E, yep. And F, good job. Now, someone this morning had a question, doing this in another class. Somebody had a question, whoa, are negatives okay? Negative outputs are fine. It's negative inputs we can't do. Remember that yesterday? So when the answer comes out negative, that's fine.
Oh, Alden has a really good saying. Nah, Jimmy got it.
What?
Alden just had a really good saying.
They were saying, Jimmy.
Can I
What'd
hear
you
it?
say?
Jimmy, it's like,
Alden said it. I forget what it was.
Jimmy said that like you can't bring negatives into your life, but you can put them out of your life.
Ah.
Yeah,
Well, I mean, you can't bring
That was
it.
Alden.
Ah!
Give yourself some credit, dude.
Oh, yeah.
Very philosophical.
I know.
Good, Jimmy.
Okay. All right, we have a couple more problems. Here we go.
Bro.
Very philosophical.
Eli, come push yourself.
You're hammered.
Light intensity and rate superior. The relationship between intensity
Brandon.
of light depth of x feet is given by this equation.
Whereas you're at that fast.
I can do the Mickey Mouse. Great.
What is the intensity at a depth of 10 feet? So basically, this is a really easy problem. All you have to do is plug in 10, right? But the issue is going to be, let me do that first. I'll plug in 10. So I'm just going to times this by 10. That's that right there. The issue is you're trying to solve for I. So we have to get rid of the logs. That has to go away. And the only way to make it go away is to loop de loop. That's how we do it.
Loop it.
Loop de loop. So 10 to the negative 0.125 no x there. Sorry, there's no x, I put 10 equals I over 12. So 10 to my power equals this thing, which is I over 12. Now, can I type this into my calculator? Yeah, I got a little button, right? So I'll go ahead and type in 10 raised
.74.
to the negative
0.750.
125, okay. Yes, it is, 0.74989, whatever, but that's not I. What do I have to do to get I now?
Multiply 12.
Multiply by
No.
12. So I is actually 8.999.
Yeah.
So this is going to be very important when we get to solving our trig equation, solving our logarithmic equation. We have got to be able to get rid of a logarithm. And the only way to get rid of one, which is all I got, is a loop de loop.
I'll have a good old
All right, that's right. Earthquake intensity. Problem B. The Richter scale is measured by this equation.
Boys focus.
In 3-6, you will be writing your own equations. Here, this is given to you, and it says, compute the earthquake magnitude for each set of values. R is the earthquake magnitude. So basically, we're finding R if A is 250, T is 2, and B is 4.25. No loop-de-loop. Just type it in. Log plus 4.25. What?
Oh, that's a fun 7.9. Or 250, log 250 divided by 2. Yeah, I got 7.9. For log 250 divided by log over 2, I got 7.965.
Okay. You want the log of this fraction.
Yeah.
So log 250 divided by 2.
Do we do log 250 divided by log 2?
No,
Oh, no, you don't do that?
It's the log of
Okay,
250
okay.
divided by 2. And then plus 4.25. What did you get now?
2.09.
What?
Log 6.3.
There we go. 6.347 basically.
Yeah.
And then B is the same thing, except they change the numbers. So it's the log of 300 over 4 plus 3.5. 5, 375.
Yeah.
Alright. 3-4 is due on Tuesday. We are now going to do a couple from 3-5 and then we'll do a couple from our review sheet.
What's 3?
Yeah, what is 3-3?
Monday.
Okay.
Yeah. Okay, so now we're gonna start 3-5, we're only gonna do a few of them though. So let's notice, they all say no calculator. Oh my goodness. Oh my goodness. No calculator. Problem number 1A. or 1A. What's the answer?
3.
3. 2 cubed is 8, right? 2 to the x equals 2 cubed, so x has to equal 3. That one is easy. B.
2.
I don't know how you got 2, I think you're right.
Come
Let's go
on.
through the steps. Divide by 3. So 4 to the x equals 16.
2. Change this 1 2 for x and then 2 3 times
X equals, well, yeah, you can just guess numbers and fill in, but what if it's 1.5? And the answer doesn't have to be a whole number. So it's best to learn the process. Nothing wrong with trial and error. Trial and error is fine,
Just that would
but
take
it
longer.
takes a long time,
Okay.
sometimes.
Okay.
All right, next one, 4 to the x equals 8.
1/2.
It is not 1/2.
Oh.
It is.
What times 2 is 16? 0.5. That's the same.
1.5.
Tell me what 4 and 8 have in common.
2.
They're both powers of 2. So 4 is 2 squared. 8 is 2 cubed. So look at what I did there. I changed my 4 into 2 squared. And I changed my 8 into 2 cubed. These get multiplied. 2x equals 3.
1.5.
And x equals 3/2 or 1.5. Is that what you said, Bruce, before? Logic, guys. If 2 to this power is the same as 2 to this power, don't those powers have to be the same? Yeah. All right, one more, and then we're gonna go to our recap sheet. Yep. We're ready for D. Three times 4 to the 2x equals 96. Now take a clue from this one. What do we want to do first? Divide by 3. If there is a number out here, you want to get rid of it, always. Even when we go to our calculator, you're gonna want to get rid of this number. So I'm gonna divide by 3. So 4 to the 2x equals 32. 32 is not a power of 4. So we're gonna have to change them both into powers of 2. The whole idea is to get the bases to be the same. So 2 squared to the 2x equals 2 to the 5th. You okay with that? So 2 to the 4x equals 2 to the 5th. So 4x equals 5 and x equals Y-force?
Yep.
The only way this problem is possible is if these two numbers, without a calculator. The only way it's possible is if these two numbers can be changed into the same base. If this number had been a 3, the problem's doable, but I need a calculator to do it. Okay? All right, so we'll stop there. Get out your review sheet that I gave you yesterday.
Airball. Get another context. Well, that's the thing right now. Like a spray bottle.
It's called recap.
That just was
Recap sheet. I did it to you yesterday. We did the first 2 problems yesterday. So now we're working on problem number 3. Come on, guys. We gotta get through at least 2 of these. Find the y-intercept and the horizontal asymptotes of these problems. Okay, let's start with this one. Would you agree this is an exponential? Yep. That number is less than 1. So would you agree this is exponential decay?
Yes.
But normally the asymptote would be right here on the axis, but now we've dropped it down 1. So now the asymptote is at -1. It looks like that. So I took care of the asymptote part. For this problem right here, the asymptote's at -1. Y equals -1. Now how do I find the y-intercept? Put 0 in for x. So 15 times 1/2 to the 0 minus 1. My picture's off a little bit. The asymptote's right, that's all that matters. Because what's 1/2 to the 0? 1. So 15 minus 1, where's my y-intercept? 0, comma 14. So in reality, the picture is like this. Alright, is everybody good with that? How do we get a y-intercept? We let x be 0. A normal exponential is going to have an asymptote at 0. This tells me that I dropped it down 1, so my asymptote's at -1. Okay? Now what about this one? Let's find the y-intercept. What is my y-intercept?
X is gotta be 0.
Put a 0 in here. So I'll have 12 over 1 plus 3. Because isn't that 1? 3 times 1 is 3. So that's 12 over 4, which is 3. So my y-intercept is the point 0, comma 3. This is a logistic function. Remember, they have 2 asymptotes. Unless you have done something like this, you know, the bottom asymptote is always going to be at 0, and the top asymptote, also called the limit to growth, will always be that, right? So you got an asymptote at 0 and an asymptote at 2 horizontal asymptotes. All right, now I need to describe, okay, so this was the sentence. functions. So here was my first kind of messed up. Here's the first one, here's the second one. We talked about this the other day. If you want to get credit for this question, you're going to answer it like a calculus student. You're going to say the limit as x approaches infinity and the limit as x approaches negative infinity. That is the end behavior notation that big kids use. Now, I'm going to look at my pick. That's for this one. I'm going to look at my pick. As I go to the right, my curve is doing what? Coming down, getting closer to -1. And if I want to be really precise, I'm not going to take off, you don't do this, but I'll put a little plus here because it's coming in from the top as opposed to coming in from the bottom. Now, what happens is I go to the left on this picture. The farther I go to the left, the higher I get. So that's it. Remember, this tells you where X is going. That's where Y is. Where is Y going? Well, why is she going to infinity? All right, now this picture. Same question. The limit to the right and the limit to the left.
Are we finding the end behaviors for the questions in 3 or 2?
Oh, I'm doing 2. So it doesn't matter, it's fine. I'm doing 2. If you want to do, I'm doing 3. If you want to do 2, you can. I'm doing 2. The idea is the same. What's happening in Y? So you tell me what happens if I go to the right? In this picture right here, this is 12. It's approaching 12. And I'm going to put a little negative there because it's coming up from the bottom of flow. And then what happens if I go to the left? 0 from the top. Yep, sorry about that, Erica. Thank you for pointing that out. All right. Next time we'll work on a couple more. You got all kinds of homework due. If you're behind, please get caught up over the weekend. You don't want to be behind over Thanksgiving.